Alright, this is going to be the review sheet number 26 quick video to help you out. Hopefully I can answer some questions and really help you out with some of these. Now this first box here, this is chapter 8, LT number 1. So this is the stuff we're covering currently. So just understand you must show work. So, you know, I kind of show you, I'll show you one. I'll just make up one that you can see so that you make sure you're following all the steps here. So let's just say I pick... I don't know, 3/4. That'll work. Okay, so this one's even harder than the ones that are there because I got two fractions involved. Okay, so first thing you always do is you always got to draw a line. We're just solving for x. Okay, then I need to ask myself what is happening to the variable. In this case, it's an x. Here it's a v. Here it's a t, and so on. You have to figure out what is happening to the variable, and then you need to undo that. Okay, well, if I know that whenever a number touching a variable means multiply, then I need to undo that by dividing by 2/5. Now, by undoing or doing what's called the inverse operation, I know that's going to leave me with just x on the left side. Now remember, this is like a seesaw or a teeter-totter, and remember, whatever you do to one side, you must do to the other. Now, you could write it here if you wanted to. You could write it like that if you want, but the way that I've been trying to help you guys is to save you a little bit of time, is to do it like this, where you actually write it up here next to this. Because you know that whenever you've divided fractions this year in because this is really chapter 3 right here. Okay, whenever you've divided fractions in the past, you've always shown it horizontally, going side to side. And then from there you would do the algorithm. So we know that the dividend stays the same, divide's going to become multiply, and the reciprocal of 2/5 is 5/2. Okay, from here you can check for cross simplifying. There isn't any. You're going to end up getting 15/8. Which that is in simplest form. Remember, we don't use mixed numbers in algebra. We do not use mixed numbers in algebra. We only use improper fractions, and that is in simplest form. So that would be my answer. Now, remember, once you get done, you always want to take that number and just quickly come up here and plug it in. So when I say plug it in, that means actually do. There's really no reason anybody should ever miss this, because you should be able to check yourself when you get done. And you actually plug it in here, check it to make sure, and you should get, you could cross simplify here. If you didn't, that's okay. 2 times 15 is 30 over 40. I know that 30 and 40 both have a GCF of 10. So that gets me to 3/4, which isn't that what we said it had to be? Yes. So that's the work I require there. The line, the inverse operations, and then of course simplifying where necessary. Okay, next box here, this is chapter 3 stuff here. Okay, so this stuff we've been putting on review sheets every single week. I don't think I really need to really explain what to do. Just remember, whenever you have mixed numbers involved, first step is to always turn them into impropers. Okay, so make sure things are in simplest form. But you know, you all know how to do this. We have covered this on every review sheet at this point. I don't think I need to give an example or anything. Okay, here we go. There were about 300 people who visited the National Math Museum this month. 2/5 of those visitors were from Mr. Edwards' class. How many students visited the museum from Mr. Edwards' class? And really the big key here, there's a lot of different ways you can do it, but the real key that I look at is I see that. Whenever I see 2/5 of, and then since of those visitors, wouldn't that be 2/5 of 300? Okay, so just think about that. What does of mean? Okay, and then you can go from there. You should know what of means, and then you can well, I just told you, multiply those two numbers together, or you can set up a proportion as well, where this is your part, this is your whole, and then it's giving you this whole right here. So you'd be set up a proportion. Okay, you could do it that way also. Okay, mean, median, mode, and range. Once again, it's something that we've had on every review sheet. Look back to past review sheets, watch back quick videos. I'm not going to tell you anything because I think you guys should have these down by now. I've been going over them every single week. How to find mean, median, mode, and range. This is the only one that I would require work on, so make sure you show work on your median. Outlier, you know what, I'm not going to tell you what an outlier is, so you're going to have to, you can go on and Google it or go back to past review sheets, but it's pretty easy. I think most of you are going to remember. And then don't forget to answer the question, how does it affect the mean? So think about what that mean does to it. Does it make it go up? Does the outlier make the mean go up or down or whatever? Okay. Now this next one, this is called a two-step equation. Okay, this is a two-step equation. This is truly a 7th grade skill. Okay, but we always like to do 2 steps also, just to get you thinking, so that it's not completely brand new come next year. So let me just show. I'm just going to do this for you. So anybody that's watching this, you're basically getting a free point here because we're going to do it together. Because it's really not hard. We're actually going to spend a day just kind of practicing, just in case, this would come up on a test. Okay, so everybody watch this. So you're going to draw a line. Everything stays the same there. Now, you still ask the question, what is happening to the variable? But as you guys can all see, there are 2 things happening to the variable. Not only is the variable being multiplied by 3, but then 5 is being added to it. So that's why it's called a 2-step equation, because there are 2 things happening to the variable. Essentially, anyway, that's why it's called that. Okay, so here's how I teach this. And we're going to have these for the rest of the year, so you may as well start getting used to this. Okay, we normally, when we evaluate, when we simplify these, when we do that kind of question, we have to follow PEMDAS. Well, when you solve, you are going to do what I call PEMDAS backwards. Now, this might seem really confusing right now, but after you do this, it's going to be so easy. You're going to think it's very easy, I think. Okay? So what that means is when you're solving and you're trying to undo, the big question is, okay, I don't know where I left off. I had somebody at the door, sorry. Okay, so basically what you're going to do is what students get confused on is they when they look at this, they say, well, wait a minute. Okay, I understand what an inverse operation is because you guys are used to doing 1 step. You look at this and you say, okay, I know I got to add because 4 is being taken from K. So you guys understand the concept. What you're struggling with is whether you're going to subtract 5 or you're going to divide by 3. That's the struggle. Well, that's where PEMDAS backwards comes into play. Okay? PEMDAS backwards. And what that means, some people teach SADMEP or something, which is that backwards, but I just like to teach it PEMDAS backwards. Okay? Because evaluating and solving are opposites of each other, right? Because evaluating, you're plugging in things and then you're trying to figure out what the value of that, like what does this equal? That's what you're trying to find out. Okay, that's the whole point. Whereas this, you know what it equals or greater than, but we'll just say what it equals. You're trying to figure out one little piece of it. So you're trying to say, like, let's say I was trying to figure out what C was, and let's say this whole thing equaled 100. Okay, they're opposites of each other, solving and evaluating. Okay, so when you look at PEMDAS backwards, basically what you're saying is I'm going to undo any addition or subtraction first. So basically what I'm telling you is since 5 is being added to it, I'm going to have to subtract 5 first, and you must do that first. Okay? Now, over here, this is where it might get a little bit tricky. Over here, you're not just going to be left with x, though. You're going to be left with 3x. And, of course, that's greater than. And then 20 minus 5 is 15. Okay? So we just basically undid the adding 5 by subtracting 5. Okay? That's what we undid. Okay, but you got to do PEMDAS backwards. So now I'm done with the addition and subtraction. Now I go on to undoing multiplication and division. So I ask myself again, what is happening to the variable? Well, 3 is being multiplied by it. Or it's being multiplied by 3, I should say. So I need to divide by 3. Divide by 3. And that's going to give me x being greater than 5. Okay? Everybody got that? So it's all about PEMDAS backwards. You're going to hear me say that a lot as we go through these because we're going to try to continue to put these on review sheets for the rest of the year. Even though it's technically 7th grade, we like to go a step farther than the 1 step so that when you get to 7th grade, you're going to pick up on this because trust me, this is part of 7th grade, but you're going to be doing stuff that's way more complicated than this. So I want you to have seen this when you go in there. Okay, now you got to graph this x greater than 5. Now my number line is kind of weird there, not like you're used to seeing. You guys are all used to seeing it as with just like then we put 0 and the opposite on there. Okay, it doesn't really matter. I don't really care how you do it. I mean, this is a whole number, so it's not a bad idea to put 5 in the middle and then 6, 7, 4, 3. That'd be fine. Or if you just wanted to redraw the thing and do one of your own, do it the way we've done it, where we put 0, 5, and then -5. I don't care. Either way on that one. Okay. Then obviously you need to graph it and graph the solution set, which is just what you need to make sure you shade it. Okay. I'm not going to do that part because that's the part that we're covering right now. But this is new material, and I wanted to make sure I did that. You would need that work. Now you just need to graph it and shade one way or another. Remember, be careful with your open dot, closed dot, and all that. That's the whole graphing part of it. It would be chapter 8, LT number 2. Okay? All right. Over here, this is an evaluate situation. Just keep in mind that I will be checking this. I will be counting lines when we're grading this. The first thing you better do is you better turn that into a numeric expression. So that means no math gets done. So simply you're going to have 4 plus 12 divided by 2, and then parenthesis, what is it, C minus A? So 12 minus 3. And then obviously from there you need to do one step rewrite and all that. Okay? All right, now this one here. Now I'm going to kind of lead you. Now this is an equation, but this is another two-step equation. That's a two-step inequality over there. This is a two-step equation. The solving doesn't change. So when you're looking at this and you're trying to figure out how to solve it, you're going to do what I call PEMDAS backwards. So you're going to undo any addition and subtraction you see first. Then you're going to undo any multiplication or division. Use this as a reference. It's the same thing. Okay? All right. Next one, this is chapter 3 stuff. This is long division. Just keep in mind something about your divisor, which will be this number. Okay, you got to make sure something happens to it, and if something happens to it, something happens to this as well. So just be real careful on that one. Look back to your chapter 3. I think it's, I want to say learning target number 7 or 8. I think it's 7. Look back in there, and it'll be division of decimals, and you'll be able to figure it out. Okay, these, which of these expressions are equivalent? So they could all three be equivalent, or just two of them could be. We're trying to figure out what's equivalent to each other. Okay, so you're going to have to do what's called combining like terms. The only difference here is there is subtraction signs. So, but nothing changes. I mean, if this was 9x plus 3x, you would make this 12x minus 4, right? Okay, that's what you would do if it was plus. Well, if it's minus, you're basically saying you have 9 xylophones and you're taking away 3 xylophones. So you need to figure out how many xylophones that would be. Okay, so you need to combine like terms or put them in simplest form, and that'll be able to get you to which two are the same. Okay. This one is kind of a different question here, the way we presented it, but not hard. Okay, now there's multiple different answers you could have on here. Okay, my answer on my answer key might be different than yours. It says you can either add an open circle or you could add a closed circle to all these. Whatever you want to do, it doesn't matter. Whatever kind of dot you want to use. But the real key here is if you do an open dot, then you got to take a moment and say, okay, I'm going to write my inequality out, and I'm going to say x. And then you need to figure out whether that's going to be greater than, less than, greater than or equal to, or less than or equal to. Okay? So basically, you not only have to put a dot on all of them, there has to be a dot on every one of that. What we're really checking is to make sure that you're doing the inequality for it. Okay? So x is greater than this, x is less than this, x is greater than or equal to this, and that's up to you. So, like I said, you can have different answers depending on what type of dot you use. Now, the good news is since they're all this one's shaded to the right, it's not like it basically eliminates. This one's either going to be greater than or equal to. Okay, all depending on what type of dot you use. Okay, so I don't think we're going to have any issues. If you do, that's again learning target number 2 and 3, all about graphing, for chapter 8, by the way. Terms, like terms. This is learning chapter 7, LT number 4, and then down here this would be number 5. So any issues there, you should look back in your Chapter 7 notes because it's all there. Rewrite that. Chapter 7, learning target number 4. Just understanding what terms are, like terms, coefficients. Really no reason to miss it because any of you is capable of looking back in your notes and making sure that you actually have your terms right, your constants, your coefficients, and all that right. So really no reason to miss it. Okay, let's go to the back. Okay, this one here, you just got to really know what the word constant and varying is. A constant rate would mean staying the same. Like if I was adding $5 every week into my bank account, so it's $5 each week. I'm adding 5, adding 5, adding 5. That would be a constant rate of change because it's staying constant. It's the same amount. It's going up by the same amount every single day. Whereas if I was, like, maybe I worked at a restaurant and I'm a server and I'm working on not only my regular pay, but then I get tips added in. And then one night I make $20 worth of tips. The next night I make $30 worth of tips. The next night I make $24 of tips. Okay, that would be what's called a varying rate. which means changing. It's not going up by the same amount or down by the same amount. So you need to figure out, first of all, whether you can see it's going to be either one of these or one of these, right? Because, I mean, that's obvious. It was kind of a dumb statement, but you get what I'm saying. Because the only difference here is these both say constant, these both say varying, but then it's all about identifying whether it's one of those, and then whether it's a rate of increase or rate of decrease. So really, two answers should be eliminated right away when you look at it, okay? All right, down here, again, we want to know which one is showing a constant rate of decrease. So remember, it's all about the output, because that's the number that comes out. It's not about what the number is that's coming in. We want to know what's going with the output. So we just talked about the word constant, what that means. So that should make sense on which one of these has a constant rate of decrease. Let's go to the next page. Okay. This one is a little bit tricky for some people. Now, we did modeling of division of fractions in Chapter 3, so really it shouldn't be that difficult because we did cover it. So if you look back in your Chapter 3 notes, you might be able to figure it out. It's all about identifying what is the dividend. And the dividend, remember, first of all, if we have a division problem, this is the dividend, this is the divisor. Okay? Remember, the dividend is the number that's being divided. So as you look up here, you got to ask yourself, what is actually being cut up right here as you look at this? Okay? And then the divisors is going to be the size of the groups or the amount of groups or whatever. Okay? So from there, I'm going to leave you with that and let you think from there. But I think you'll be able to figure it out. And there's a couple answers on there that really don't make any sense at all. You can eliminate two almost right away, or at least you should be able to. Then it comes down between two others, and I think you guys will reason through and be able to figure that out. So since it's multiple choice, I'm not going to give too much more help than that. This one, we have a board that is 3/4 of a foot long. So they put it on a number line. I don't have any issue with you guys if you want to just quickly make my board. There's my board. Okay, and that's how long it is. It's 3/4 of an inch long. He wants to cut it so that each piece is 1/4 long. Okay, so that's the size of the piece. Okay, how many pieces can James cut from the board? It's a problem that anytime you know the whole, and that would be the whole length, you know it's got to be a subtraction or division problem. So from there, you need to think about when we're talking about size of pieces or amount of pieces, which it's giving us the size and asking us for the amount of pieces, you should know what type of problem that's going to be. Okay, so I'll let you go from there, and obviously you would need work there and all that. Okay, and then it asks a couple more questions, I think, or at least explain how you were able to get it. So I want an explanation there. Okay. Let's go on. Okay, we have a leaky faucet example here. This leaky faucet was basically, it's showing the number of minutes that go by and the amount of teaspoons of water that were dropped. This is the teaspoons here, this is the number of minutes. So as you can see, after 6 minutes, this faucet actually was, let me do that in a different color. This faucet actually leaked out 2 teaspoons. I mean, that's how it works. Okay, just like here, they got it marked here. Over 10 minutes time, 3 1/3 teaspoons leaked out of that faucet. And then here you can see 15. It's about right in the middle. 15 minutes went by and they lost 5 teaspoons of water. Okay. So now you just gotta basically, you could do it a couple different ways. You could do proportions here if you wanted to, because you know this. I mean, this right here is a fake ratio, right? 6 minutes and 2 teaspoons. That's a fake ratio, and it gives you minutes. So I mean, you could absolutely do it like that, or you could just look at your graph and go to 12 and then figure out what that is. Okay, so that either way on that one. But proportions, I always encourage people to use proportions. Down here, this is another. I would definitely need proportions here. This is a no doubt proportion question here. It says the table shows the sales tax for the purchase of $1,200. So basically, right here was your purchase amount. Then this is the tax that went on that $1,200. So right there, that's going to be your fake ratio. That's fake. Okay? So then it's going to give you some sort of real information. It's either going to give you a tax amount or it's going to give you a purchase item amount. It is asking you, whoops, what am I doing? it's actually giving you that right there. The real information would be the amount of the purchase cost. You need to figure out the tax amount. And we're basing it on that. We're basing it on that. So here's your fake ratio. There's your real information. You should be able to solve it from there. Okay? All right, guys. I hope this helped.